I finished the decking, balustrades, deck lighting, and landscape lighting, everything but the roof during the spring, summer, and early autumn of 2019. I had plans to do the roof starting spring 2020 when I realized I could build the cupola and octagonal ridge board during the winter in between. The first thing I did was cut out the platform, which became the top of the scaffold that was to support the octagonal ridge board. The cupola would rest on that. Before I did anything though, I made sketches and measured drawings of what I wanted. Here's a scale drawing of the elevation of the cupola. I wanted to get an idea of the scale of the cupola in relationship to the roof. It turned out it was very close to 4 feet by 4 feet, so I figured I'd go with that size. This is a framing plan of the cupola. Here's how I cut out the octagonal platform. I found a way to draw a regular octagon on the internet. By the way, a regular octagon has 8 equal sides. Step 1 says start with a square. Step 2 says find the center of the square by drawing the 2 diagonals, then set the span of your compass from one corner to the center. So, where do you get a compass that can accommodate a 4x4 piece of 1/2 inch thick plywood? You buy yourself a trammel. What you get when you buy one are the 2 trammels. One holds a needle point and the other a pencil. The heads clamp onto a straight piece of wood. But how do you get the needle point to stick into the corner of the plywood? I solved that problem by screwing down a piece of MDF over each corner. Then, using a speed square and holding it against the side of the plywood and placing a 12-inch steel rule on the square, I was able to extend a line onto the MDF and mark an intersection that showed where the corner of the plywood was. Step 3 says set the needle point of the trammel on one corner and the pencil at the center of the square. Now swing the trammel and mark both adjacent sides from that corner. Step 4 says do the same for each of the other 3 corners. From those marked points on the sides, I drew lines from one adjacent side to the other. Lastly, I screwed down a straight edge as a guide for the circular saw and made the cut. By the way, screwing down the straight edge eliminated clamps getting in the way of the saw. With the remaining 3 corners cut off, I had a perfect octagon. Next, it was time to cut the 16 2x8 pieces for the octagonal ridge board. The first thing was to set the miter saw to 67.5 degrees. Here's the first pieces cut to size. The octagonal ridge board is going to be 3.5 inches thick. That's 2 2x8 lengths for each of the 8 sides, with a 1/2 inch plywood sandwich in between. So that gave me an outer ring of 2x8s, a middle ring of 1/2 inch plywood, and an inner ring of 2x8s. I only made the outer ring at this time. The 1/2 inch plywood and inner 2x8s I installed at the site later. I used 2 Bessie strap clamps to hold the 2x8 lengths together, then drove 3 3.5 inch wood screws at each corner, 2 from one direction and 1 from the other. Here's the 8-sided platform and the octagonal ridge board. Next was to build the top and bottom plates for the cupola. I used pressure-treated 2x4s to make them, as they would be exposed to the elements. I cut the 16 pieces, 8 for the top and 8 for the bottom plates, and used 2 biscuits to secure them to each other. Then I used Bessie strap clamps to hold them tight together. Lastly, I drove one 3.5-inch screw at each corner. I dressed up the 2x4s by routing the outer edges with the roundover bit. I finished up the top and bottom plates at the same time. Here is the completed outer ring of the octagonal ridge board and top and bottom plates. Now it was time to make the lattice windows. I started by laying out the bottom plate and studs where the parts of the lattice window will be. I'd purchased Rockler's shutter jig a few years ago to make the shutters for my workshop. Here I set up the jig to cut the slots for the louvers. I used my router bit to cut the slots. I dressed up the stiles with the bead bit, and then the stiles needed to be cut at 67.5 degrees. Here's what they look like completed. I cut the louvers from 2x4s. The first pass made the slats 1.5 inches by 1/4 inch. The 2x4s were already cut to the proper length. The second pass cut them to the proper width. For the next step, I had to set my Craig router table so that the outfeed fence was slightly forward of the infeed fence. Each of the 80 slats needed the corners rounded. Each slat went through the router 4 times. The rails needed rabbets, as you'll see why. See? That's why. It prevents the rain from dripping behind the bottom rail. And a dry fit just to see how it looks. All of these pieces were made out of pressure-treated lumber. Since they were so extensively cut, I needed to douse them all with wood preservative. Now here's a simple jig for putting the louvered windows together. It ensured that the windows would be perfectly square. This is what a finished window looks like when you've accidentally dropped it. And here's a dry fit to see what it looks like. It was time now to do the rafters for the cupola. What I needed first was a ridge post. I took some leftover 2x8s and cut them to size, then glued them together and left them to dry overnight. The weather vane will be sitting in a 3/4 inch diameter by 4 inch deep hole. My benchtop drill press only went so far. I had to finish the hole with a drill and a 3/4 inch spade bit. Marking where the corners needed to be cut, you can just see the table saw blade set at 45 degrees. And all 4 corners cut. When I was planning this, I thought getting all 4 corners cut equally would be difficult, but it wasn't. Here, I just put 8 scrap pieces of 2x4s to see if the rafters would fit. The pitch of the roof was supposed to be a 612. A 612 needs to be cut at 63.4 degrees. I screwed up because I didn't take into account how the notch I made at the corners of the top plate where the rafters would be sitting would affect the angle. It turned out the angle of the cut for the rafters had to be 66.4 degrees. All 8 rafters cut. Studying how the first rafter will be attached to the ridge post, it turned out putting a 2x4 under the rafter lined up the rafter perfectly with one of the sides of the ridge post. Sometimes things work out right. Earlier, I'd made a measured drawing, then used that drawing as a guide to connect the rafter to the ridge post. Here's the drawing next to the actual pieces. I inserted a 3/4 inch dowel and marked how deep the hole was. I used that dowel to test that the tips of the screws didn't penetrate into the hole. Here's the angle of the 3.5-inch wood screws I planned on using. I drilled 2 holes, one in the rafter that was just big enough to allow the screw to slide in. The hole in the ridge post I drilled just big enough to let the threads of the screw bite into the wood. Here's the 2 drill bits I used, and 2 screws held the rafter to the ridge post. I pushed the dowel into the hole after attaching each rafter to check that the screws didn't penetrate into the hole. In one case, the dowel wouldn't go all the way into the hole. A 3/4-inch drill bit solved that problem. Fortunately, it only happened once. I marked where I'd cut a notch in the top plate that the rafter's bird's mouth would sit. Then I cut the notch. This is the notch I mentioned earlier that offset the slope by 3 degrees. With 2 opposing rafters connected to the ridge post and the top plate, I could now attach the rest of the rafters. The ends of each rafter had to be cut to accommodate attaching the fascia. Unfortunately, that meant having to dismantle the rafters from the ridge post and top plate. The rafter attached to the top plate with 2 3-inch screws. And here's the rafters attached to the ridge post and staining the rafters and ridge post. This shot always reminds me of a dead spider. I laid down the 1x6 tongue and groove boards face down on the rafters. Then I measured and marked where the boards had to be cut. The boards are all fitted but not nailed down. That will happen when I make the final assembly at the site. I measured each section for the plywood, then cut them out and laid them on the cupola roof. They were held in place with 2 screws each. Final assembly will also be at the site. I pre-cut all the shingles. Here's the cupola roof with everything cut, including fascia and drip edge cut and screwed. When it came time to install the cupola, I took it down to its component parts and reassembled it at the site. Assembling the lattice windows. The windows were originally going to be assembled at the site, but when I tried to dry fit them, I found it to be too difficult. I was able to get it all together in the workshop, but it required clamps and a lot of finagling. Trying to do it on the roof of the gazebo would have been next to impossible. The lattice window assembly you see here was separately added at the site.